Once again, welcome back to ELECTRECA, and thank you for watching. Okay, like I told you, today we be looking at phase failures. Phase failures, and like I'll demonstrate to you. Phase failure, it's according to the way the name sounds, it protects more especially the motor, those drives, because basically that's why we have such a thing, such a protective devices inside incorporated inside our circuits. So this phase failure, one, it helps us to avoid single phasing, because single phasing is very common in electrical circuits in three-phase. Perhaps a fuse at the supply transformer can blow, and your circuit is on, your motor is running, your three-phase pump is running. What happens is one phase will be a variable, and if you don't have this, definitely that motor will blow. Single phasing is really bad to drives. So then the other thing that it protects your drive from under voltage and high voltage. So for example, if in your country, like in our country here in Kenya, our current, the voltage, the supply voltage is always 415. So when you're setting your parameters, you should set the threshold on high and low. So for example, if it's 415 and perhaps if it comes maybe 500, so that's high. 420, that's high. So you do set between there, maybe at least 415, then 417 it breaks. Then under voltage also, because you know very well that also under voltage can ruin machines. It's really really bad for it. Then the other thing also, what it does also, it help you with the sequence. Most of our pumps, more especially pumps, the pumps always to do their work, they must rotate in a forward direction or in a clockwise direction. So if a pump rotates in anti-clockwise, then it won't do what you want, because it must always in clockwise direction for it to be able to, to pump that water. So perhaps if, let's say, for example, maybe anything happened at the transformer, and then maybe perhaps they change the lines. So when they change the lines, then your pump will do it backward. So what happens is that this same thing can help you with the sequence. When the power come on, it will detect that the power is reverse, and then your circuit won't be engaged. So when you come, you can simply, because you want to go to the transformer to change that, then you definitely have to, sorry about that, you definitely have to change inside your panel by yourself. Yeah, they are quite common in different ways. Normally what we do, more especially the sequence one, is always better for drives, motors, pumps. It's always better because it helps in the sequencing. But if you're just doing a normal changeover, a normal three-phase automatic changeover, you can use that, which only sees the phases. And also high and low voltage. So let's go to the panel and we demonstrate how this works. Okay, let's continue on where we stopped. Now, This is now our phase failure, this one. And like I explained already, this phase failure, we use it in our circuits, three-phase circuits, to control motors. And basically, like I said, its work is to monitor phases, availability of phases. In case any phase, is out, definitely it will save your drive or your motor from burning, because if a motor or anything like that, if it's single phases, then the winding will definitely burn. Now, the reason why I brought you to this box, because I wanted to show you how a typical phase failure looks like. This box initially was for a changeover, was a pump control. If you look critically there, you see we have a contactor there, three-phase contactor, we have 3 breakers, we have a phase monitor and a float trace. But right now our very focus is on phase monitor, how it controls the circuit and how it helps the motors to work normally without any worry of burning. Now, right now our circuit is off. Right there, it's a breaker. This one, it's a circuit breaker. Actually, it doubles. It's a breaker and a relay, override relay. And then we have our contactor here. Then these breakers breaks the lines that goes to the phase monitor. Okay. Now, let's assume that now we have a motor connected and this is our circuit. And we want to see how the phase monitor works. Now remember that in your control, I'll draw for your control. From your control, remember that the phase monitor controls or supplies the control of this circuit. In that, if there is any phase that is lacking, definitely the phase failure will cut power off, meaning the whole system will be off. And also, if I can zoom in here, you see it has got some knobs there where you can change parameters. There is the under voltage and over voltage. So, and then down here we have a delay, on delay. Now, the under voltage is basically will mean that you can set the threshold for the under voltage, such that if power on a certain phase goes down at a certain threshold, then the circuit will be off. Because remember, if one phase there is no imbalance in the circuit, especially in the motor circuit, of course you will lose your motor. Then over voltage also same thing. If it goes higher, still it cuts. That's why it has got 2 lights there, 3 lights there, the green one and the 2 reds. So if you find the 2 reds, one of them is on, you can tell if it is under voltage or it's over voltage. Now the on delay is how much time do you need before it switches the circuit on again. Because remember, perhaps it's a pump and it will be automatic. You don't need to be there. The phase failure will cut off, and then when it senses that power is ready, it will switch on back immediately. But if you had set a delay, because in seconds, you see, if you look closer, you can see there 3, 6, 9, 12. You see that? So you are able to press, and then which delay you want to give it. 15 seconds, but of course it shouldn't be 0. Yeah. Okay, now let me show you how this one works. Now the first thing we are going to do, there is a phone down there that is helping me to give me some light in this box. We will switch on here. Remember, you must be very, very careful while dealing with electricity. You must be always take your safety precautions, because electricity is very dangerous and it can kill. Alright, right now I've powered my circuit on, and you see the phase failure, it's on, and it is telling us that everything is okay. And if I try right now to start our pump, you will see that our pump, our contactor will energize. You see? Now our contactor has energized. It's on, and then I can switch it off. You are able to see our contactor is able to go, so that means that our drive can run safely. But now let us assume, sorry about the shaky, okay. But now let's assume that one phase has gone out. Now, what I'm going to do is I'll just switch off one phase, like this. So I've switched off one phase. And if you come and then the circuit is out, because of course you'll have some indicators that will be showing you on the screen whether your power is available or not. But at least you'll come and you find that your phase failure is not on. Your phase failure is not on. So it will tell you that there is something wrong. Then when you come with a multimeter, you can test, and then you find out where the problem is. But in case, because the system is automatic, if our phase comes back on, you see, that's it. So it goes back on. And again, if we are to press our start, still our start will make our circuit complete. Alright, so thank you very much indeed. Hope you've learned something. And please don't forget to subscribe, to like, and if you have anything that you want to compliment, to add on, you know, might be anything you want to say about this video, please don't hesitate. Put the comment down there. Even if there is something that you didn't like about the video or about my explanation, you can still put it down in the comment. Thank you very much.